So this lesson is on forward and backward scans. In the previous lesson, you would have worked on drawing a PERT chart and doing some Nat5 apps past paper questions to do that. Today, what we're going to do is turn our PERT chart or complete our PERT chart rather with a forward and a backward scan. So what I need you to be able to do today is complete the PERT chart showing what's called the earliest start time and the latest end time for each activity. Success criteria is create the PERT chart, that's really from last lesson, showing the durations. Carry out a forward scan, showing the earliest start times, and carry out a backward scan to get the earliest end times. So, a forward scan. A forward scan is a method for determining the earliest possible start time for each activity. We always work left to right. For activities that don't have a predecessor, now, a predecessor just means an activity that comes before it, so to the left of the activity you're looking at. So for activities without a predecessor, the earliest start time is 0. So what that really means is any activity at the far left of the picture, start time is 0. For an activity that has a single predecessor, so just one activity that comes before it, the earliest start time is the sum of the predecessors, the previous activity's early start time and duration. If an activity has multiple predecessors, so 2 or more activities that feed in, then what we do is we take the maximum sum from all of the sums of its predecessors' early start times and durations. So I would recommend having that slide in front of you when you're trying these questions, but you'll see there's a lot of words. There's a lot to maybe think about here, but you'll see when we get to the example really what we're looking at. So let's go back to our baking a cake example from last lesson. So activities A and C have no predecessors. They are at the start of our project. So their earliest start time has to be 0, and we just fill that in. That's easy enough. Activity B has one predecessor, activity A. So its earliest start time must be the sum of activity A's start time and duration. So 0 plus 5 will be 5. Activity D only has the one predecessor, activity B. So we take its early start time and duration, 5 and 2, and that makes 7. Now, activity C, let's fill this part in. Activity C has an early start time of 0. Oh no, we've already done activity C actually. So let's look at activity E. Activity E has 2 preceding activities, D and C. Right? And what we need to do is take the maximum of the sum of the early start time duration. So activity D starts at minute 7 and only takes 1 minute. So 7 and 1 makes 8. Activity C starts on minute 0, takes 15 minutes. So 0 and 15 makes 15. So we take the maximum of those, 8 and 15, so that would be 15 in this case, and that is activity E's early start time. Then we go on to G and F. So G and F are 2 activities which happen at the same time, and both of them, G and F, only have the one preceding activity. So that means that the early start time for G and F are the same. So what we're going to do is we're going to add up 15 and 20 to get 35 and put 35 in for both of them. And then H has 2 preceding activities. So we need to take the maximum of the sum for G and F. So 35 and 5 makes 40. 35 and 10 makes 45. So the maximum is 45, and that finishes the forward scan. We take activity H and put 45 for its early start time. So this lets you start to see where the maybe float time is in the activity. So for instance, take activity G and F here. Activity G only took 40 minutes, but activity F will take 45 minutes. So therefore, there must be 5 minutes float time within activity G and F. So just lets you start to interpret the picture a little bit. Right? It's not really important for this lesson, but it will be in the future lesson. At this point, that's the forward scan finished. And what I would maybe recommend you do is just pause this and go and do question 1A and B from exercise 21.2, but just do the forward scan. Then you can, once you feel like you've got a grip of that, you can come back to the video and do the backward scan. That's maybe better than just watching it all in one go. So feel free to pause and move on. Right, so if you've come back then, we're now going to take a look at a backward scan. So a backward scan is a method for determining the latest possible end time for an activity. So we always work from right to left. For activities with no successors, now what I mean by a successor is the opposite of a preceding activity. A successor is an activity to the right of one of the activities you're looking at. So if you're looking at activity B and it has a successor, an activity C to the right, that is its successor. So for activities on the far right of the picture that have no successors, the latest end time is just the length of the critical path. For activities with a single successor, the latest end time is a difference between its successor's latest end time and duration. You'll see an example of what I mean by that just shortly. And if an example has multiple successors, so two activities to the right of it, then we take the minimum value of these differences between the successor's latest end time and duration. So let's go back to our baking a cake example. So activity H is on the far right hand side of the diagram. It has no successors, nothing to the right of it. So its latest end time is just the length of the critical path. And without having the rest of the diagram there or looking at the rest of the diagram, we can just add this up. 45 and 10 makes 55, and that's its latest end time. So then we go into activity G and F. Now G and F only have the one successor, activity H. So to get G and F's latest end time, all we need to do is H's latest end time, take away the duration. So 55 take away 10 is 45, and that goes in both boxes. And again, that just highlights that G is going to have this 5 minutes float time in it. So its earliest start time is 35, it takes 5 minutes, and its latest end time is 45, so it has 5 minutes float time. Whereas activity F, 35 and 10 makes 45, it's a critical activity on the critical path. It does not have float time. It cannot afford to be delayed. Now, activity E has two successors, G and F. So activity E, what we need to do is find the maximum difference between G's latest end time and duration and F's latest end time duration. So 45 take away 5 is 40. 45 take away 10 is 35. So E's latest end time must be 35. We need to take the minimum of the latest end times. So 45 take away 5 is 40. 45 take away 10 is 35. The minimum is what we put in E's latest end time. Okay. So moving on, right? Let's look at activity C, right? So its latest end time, it's on the critical path. Its latest end time must be 15. Okay, it's only got the one successor, activity E, and 35 take away 20 is 15. So that goes in there. Okay. Looking at activity D only has the one successor, E. So again, its latest end time must also be 15. Looking at activity B, only has the one successor, D, and 15 take away 1 makes 14. So its latest end time is there. So you can see that there's 7 minutes float time in activity B. And then finish on activity A, looking at B, 14 take away 2 is 12, so the latest end time for A is 12 minutes. That's a backward scan. All right. So just highlighting here the boxes in yellow. These are the critical activities. These make the critical path. They're easy to identify because the number on the left plus the number in the middle makes the number at the end. So that's how you know that these are your critical activities. Versus the ones not shaded in yellow, where 7 and 1 makes 8, for instance. Well, 8 all the way to 15 is another 7 minutes. So there's 7 minutes float time for activity D. Right? So that's how we identify the critical path. And finishing there, a forward and backward scan activity, exercise 21.2, page 175. We're going to do question 1A and B. We do the backward scans if you've already done the forward scans, then C, G and H, and then I need you to be able to do question 2, all of it, because the full sequence is making the PERT chart yourself, so putting the activities, the durations, the forward scan, the backward scan, and that can all be worth up to 10 marks in the exam. So it's definitely a good one to be able to do. Use the Write On worksheet in the lesson folder, and yeah, enjoy.